essentially. And then we'll introduce Tensorflow, the basic functionality you have in the package Tensorflow tomorrow. The idea is, the Tensorflow is designed for people to work with so-called Tensor. We'll introduce what it is later. And once you could work with Tensor, you could actually deal with a lot of different topics. But we're going to focus on deep learning for neural network. The neurals you see in a lot of images and connect. Those neurals are actually connected by the so-called tensors. So we're going to start from that. Today we're going to talk about foundations, the theory. Why do you have those neurals and how they are connected to one another? Once you have the basic idea, some big picture of the whole modeling process, hopefully you'll find it more intuitive when we talk about the language or the package tomorrow. Okay? So first of all, we need to start TensorFlow. So all the demonstration, the example we're going to do, that we're going to do is on TensorFlow. It's in Python. Okay? So you already sent the instructions to you guys. If you already pip install TensorFlow in your own Python, that's usually fine. Okay? If you have problems to do that, we actually create a so-called Docker instance for you. So Docker is like a virtual machine where all the setting is done. Okay? So all the paths are in the right place so that when you run TensorFlow, everything's going to be right. You won't have any version issue. So let me show you how to do Docker. Okay, I'm going to do the lecture in Docker. So first of all, we have to navigate to where you save the lecture code. If you haven't done it, you could go to the course web page and download this TF101. It's really, most of the course, the TensorFlow course will start. So these are 2 items that you got, and Jupyter Notebook, and another slides in PDF. So then you will go to your terminal. By the way, this is for if you want to start TensorFlow with Docker. If you already have TensorFlow starting your own Python, that is fine. You don't have to follow this. Okay. So let me go to desktop, TF101. Okay. And then I would like to start Docker, which I do have the command here. Let me make it bigger. You don't have to type this because it's supposed to be in the instruction that Zeri shared with you. Depending on whether you're using Mac or Windows, if you're using Mac, you do exactly this. If you use Windows, there's a little difference. What happened here is we're going to create a virtual machine, okay? And then we're going to run TensorFlow in virtual machine. However, you do want to see the result in your real computer, right? So what happened here is the virtual machine has the ports. We're going to use 8888 port from virtual machine and then connect to the 8888 to the real machine. So when you open your browser, you type localhost 8888. That is the 8888 port from your physical machine. And then it's going to extract the information from the virtual machine. Okay, so these are 2 ports that you connect your virtual machine and the physical machine. 8888 is for Jupyter Notebook. Okay. And then we open another port, which is 6006. That is for TensorBoard, which we're going to see maybe tomorrow. So any questions so far? Just you do the computation in the virtual machine, and you want to connect to your real machine so that you could see the result. That's why you have to specify which port you want to connect them. TensorBoard is the same thing. And then you would like to connect this is the current, so I'm sorry, I was wrong. It should be the other way around. The first 8888 was the port in the physical machine. The second one is on the virtual machine. And if you look at to connect the folder. So PWD is a present working directory. the directory we are right now. In my case, it's the desktop TF101, because I already changed the directory there. And then I would like to sync it with the data folder that I will have in the virtual machine. So in my virtual machine, it's just like a your terminal. And then what I would like to do is to have this /data folder, and then I want to sync that folder with my current working directory. Is there any question? So that's about this command. And then this part is just the name of your virtual machine. You have a bunch of settings writing inside somewhere. Okay, you have to specify where you want it, what kind of setting you want to fetch. You have to use the name of the container. So you want to get all the settings from this container to launch your virtual machine, to launch your Docker instance. So this specifies what kind of machine you're working with. And the last one, the bash, simply says we're going to use the terminal, use the command line. So if you just go ahead and run it, okay. Now we see that we're in a Docker image, and we're currently in the folder /data. Is there any question? You have which one? You haven't installed Docker. All right, so now I'm in my virtual machine. It's no longer in my local machine. One of the evidence is so anyway, we are in our virtual machine, but it is sync with the TF101. So I do have my Jupyter Notebook here, and I can go ahead, start my Jupyter Notebook. And once I start my Jupyter Notebook, I can get this part, just copy and paste this part, and put it into the browser, so that I could see the Jupyter Notebook. Even the computation will be done in the virtual machine, I could see the result in my physical machine. Yeah. Yeah, I went to the folder where I save all the lecture code. So let me just do that. All right, so that's where we start. If you install Tensorflow in your local machine, it's okay. Just start it, and as long as you see the notebook, that's good. Is there anybody? Does anybody still have problem to start to find a notebook around Tensorflow? I think. Okay. So some people will still need some help. That is okay. Let me slowly start the lecture today. I'm going to talk about some basic function before I get to the real neural network. Let's just talk a little bit about some basics in TensorFlow that you will need to use. And for people who actually need help, you could, Zeyu is there, you could turn to him to start your TensorFlow. So to be able to use a package, just like when we use NumPy, we have to import it. To use TensorFlow, we just import TensorFlow as TF, as an alias. TensorFlow is actually under construction. They're changing very fast. So you're going to see this kind of warning message very, very often, unfortunately. If you just open your If you have already opened the notebook that we use for tomorrow, if you look at the output of the Jupyter notebook for tomorrow, you see that the version we used last time, which is just 3 months ago, it was Tensorflow 1.5. And if you go ahead install Tensorflow and run it again, you'll see it's 1.8 now. So they're changing very fast. So you don't have to, when you learn the whole stuff, you don't need to worry about these warning messages too much, as long as you understand the basic. Here we're going to use something called the interactive session. Okay. We're going to talk about the detail about TensorFlow more tomorrow, but there are two basic components in TensorFlow. When you do the computation in TensorFlow, there is something called graph, and there's something called session. Graph is where you create all the object that you need to use. You need a variable, you need a constant, you need a gradient descent optimizer. All those stuff you create in the graph. And then once you get all the object ready, you want to run some computation, you do it in a session. Here we only see session here, we don't see graph. It is just because if you don't specify any graph, TensorFlow will create a default graph for you, and all the object you create will be there. Unless you want to deal with multiple graphs, usually you don't have to worry about that. Through the course today and tomorrow, we actually don't need to worry about graph too much. And here we have a session. We're going to show you different kind of session or different usage of session tomorrow. But today we're going to use an interactive session that is especially good for Jupyter Notebook. You don't have to worry about the format or the order or anything. The only thing you need to keep in mind is you start a session with an interactive session function. You do all the computation in between, and you have to close the session. That's it. Okay, all the computation will be done here. And it doesn't, you don't have to put the session.close in the same cell as the same cell as the interactive session function. It could be somewhere later. It is okay. Just keep in mind all the computation has to be done between interactive session and session.close. That's it. And here, I'm sorry. That's the session and session.close. Any questions so far? And these are the typical TensorFlow object. Okay, we have variable, we have constant, we have a placeholder, which we're going to introduce later. But here, we just create two variables. Let's say it's an object, and we can specify the value of the variable. So we do want to have k, in a sense, this is just k equals 90, L equals to 9, and that's it. And then once you create a variable, you have to initialize them. Okay. For people who are familiar with lower level language, well, some other low level language like C++, when you create a variable, you do have to initialize them. In Python and R, you don't have to do it. You just do a equals to 9 and do whatever you want to a. But for main language, you actually need to initialize it. Here's just the same thing. We would like to initialize, so this is a global variable initializer. That means we just go ahead and initialize all the variable that we have. It's a convenient function that we could use. You don't have to specify which one you want to initialize. Just initialize whatever you have. And then initialize is a process. You specify I want to do this process, and this .run method actually do it. It's a bit like when you do linear regression. You do linear regression parentheses to create a linear regression object, and when you actually train, you use .fit. And this is a bit like that. You specify a process and actually run it with this function. Once you run it, these two variables are initialized, and then you could do the addition. This is just adding k and l together. Once you add them together, again, this is just a process. It says that you have variable k and a variable 9, and this process means you want to add it together. To actually see the result, you have to use this .eval to evaluate this process. And the evaluation gives you, just 99. Okay, so it's 90 plus 9. That gives you 99. So you see that to do 90 plus 9, it takes several lines. So if it's just addition, you definitely don't want to use TensorFlow to do it. Right? You want to use TensorFlow to specify more complicated process here, and then eventually you want to evaluate the result, right? So, any questions so far? Please. Mm-hmm. Well, you can start multiple notebooks, even just start multiple notebooks in your local machine. But you have to make sure that they go to the different port. If 8888 has been used, then you have to use 8889 or 8890. Just, the output has to go different places. That's it. Mm-hmm. Otherwise, you won't be able to see it. It's in the virtual machine. It's done in the virtual machine. And then the result is output to your... The browser is running in the physical machine. You don't have browser in your virtual machine. So the result is sent out to the, real machine. Yeah. Mm-hmm. So then, if you wanted on the same computer to run your local computer notebook, yeah, you could just go to your user and just run Jupyter notebook, and a regular notebook will be running. Yes, 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 that's okay. Mm-hmm. All right, and then those are the basics of TensorFlow, how computation is done, and I would like to introduce the data set that I would like to. Our toy data set for a demonstration. This is called a Venice Data Set. How many of you actually know this data set already? Okay, that's fine. This is actually probably the most famous data set for image classification. What you have is sorry. So the data set is like this. The data set, if you think about the data as a tabular data set, it's a table. Each row represents an image like this. An image like this. This is the first row, this is the second row, this is the third row. And they're encoded into a vector of numbers. How is that done? So in this image, you actually have 28 times 28 pixels. Is that okay? So you have that many dots in the image. And each dot comes with a number, tells you how dark so is. Excuse me? What is that? I guess so, yes, bitmap. Sounds right. So it's just a number from 0 to 1 tell you how dark each point is. And you have totally 28 times 28 dot. So each row represents an image. And because image classification is a classification problem, we're going to predict something, so we need a label. The label for each row is just the actual number or actual value that the image represents. So this will be 5, 0, 4, 1, 9, right? So as you can see, we have the input or the independent variable and the dependent variable. Is there any question about that? Yeah. Say that again, I'm sorry. So this would presumably do well if it were unlabeled, but you knew that there were only 10 digits. Yes. Yes. Yeah. Yeah. You have to, well, before you train the model, you have to specify the collection of labels that you have, right? And then TensorFlow actually it provides this function for you to load a data set. This is really nothing. It's not a special function. It's not deep at all. You just use this input function to read the data. You want to read the Venice data. Okay. The data set is hosted in Jan LeCun's website. You could click on this to take a look at this web page. But in any case, the data set that this function load is from this web page. And if you go ahead to try this function, you probably will see a lot of warning message. Oh, I don't, because I'm using older TensorFlow version. If you do it now, you might see some warning message, because they try to separate the tutorial from the main package. So there's something on the, they're actually doing something right now. That's why you see those warning message. But as long as you can load the data set, it is okay. Make sure everybody load the data set successfully. If you have any problem, it's fine. It's fine. It's fine. Later, it's likely that this function will be deprecated. Okay. Yeah. You're getting error? It's likely to be the connection problem. So you'll probably try it a little bit later. Okay. Or another way is you could just go to this web page and download it manually, put it into the folder, and then run the function again. Okay? So now we got this object Venice from the function. Does anybody know what kind of object do we got? This is actually a Python question. You got a new object, what should you do? How do you take a look at it? How do you know what you actually get? Yeah, that's actually a good approach. You got it. You could use a dot and probably hit the tab to see what you get, right? Similarly, you could just use dir as I did before to see, to see all the attributes you have. And of course, you might want to take a look at the documentation to see the structure of this whole object. But essentially, what we need to do, what we need to use is a training data set, test data set. In addition, they also provide us a validation data set. What's the difference between, what do people think the difference might be between the test data set and the validation data set? Any idea? Any guess? Oh, I think that's right. But why does, so the answer was one has a label and one did not. Well, actually, all of them has a label. Okay. But I think you got a very important idea that one of them should have the label, but the other should not. Why is the case? Why do you think that way? One is for cross-validation, the other is to actually test your model. But it's not cross-validation, it's just validation. Validation is for tuning your parameter, okay? So usually, you will use a validation set to tune your parameter. For example, if you use regularization, you could use regularization for neural network as well. You use a validation set to figure out the best lambda is 100. I made this up, but it's just 100, okay? You figure out this number, but because the process you figure out the number lambda already has this validation set involved. So it's not appropriate to test your final model, the model with lambda equals 100, with this data set anymore. You would like to use a test data set. Okay, question? It's for grid search, yeah. So, it's not cross-validation. And why is that the case? Why don't we want to use cross-validation? Why do we want to just use a validation data set? for this particular case. Yes, yes, because cross-validation is so slow. And that's one of the very important factors that you need to take into account when you train a model. So when the data is huge, we'll deal with image. You have to, well, if you don't have enough time, you don't have the, you probably don't want to do cross-validation, just go ahead and do validation. And that's why when people train neural network, which is also a complicated model, they usually do it this way, just a simple hold-off strategy. All right, so from the MNIST object that we got, we could try to get the train. And if, again, you could use a DIR function to look at that. Well, probably I should do it. So for the MNIST, let's get the train attributes. And again, you probably need to read the documentation to figure all these attributes. But what we are going to use is the image and the labels. The image is the say that again? How can you not? What did you get there? Oh, so dot train. The train data set comes in image. Okay, so what I can tell, because I already know this data set, the image is actually what happened. It's images, sorry. The images are just NumPy array, okay, and the shape of this NumPy array, but because this part is NumPy array, we know it. NumPy array comes with the shape. You could take a look at it. And the label is another NumPy array. It also comes with the shape. So I print out a shape. This is what we got. The shape of your images is this. The images of your label is this. So does anybody want to guess how we end up with these numbers? What does 55,000 mean? What does 10 mean? What does 784 mean? Please?
55,000 observations.
Okay.
And then 10 attributes or columns. 10 columns and 784 is 28 squared.
Right. Right. That was correct. That was correct. So 55,000 rows. Right? It's a convention that each row is one observation that tells us in our training data set we have 55,000 images. And the 55,000 images comes with 10 different, in the label, it comes with the 10 columns. That is just a domified or one-hot encoded. We met some 4-hot encoders yesterday. And it's just one-hot encoded of the labels. The labels are just 0, 1, 2, 3, 4, 5 up to 9. So after you do the domification, you got 10 columns. Is that okay? For the computation, you don't really remove the one redundant column from the 10. Usually when you do the domification, one of them can be derived from the other, right? So you will remove it. But for the label, when you want to use their function to compute your likelihood function, we're going to see that later. You just keep all the 10 columns. You don't have to remove anything. Just keep it this way. And 784, that means each image comes 784 features. Each image comes with 784 features. They are just the 784 pixels that you have in the image. It's just 28 times 28, so you have totally 784 dots in each image. Each dot gives you a number. So that's the data that you get. Is there any question? And I feel like people are pretty much ready, so we could go to the neural network. Here's a little side issue. Okay, if you use R, you could always save whatever you want into R data, right? So if you save your data frame into R data file, .R data file, when you load the .R data file, you got a data frame back again. But if you save in CSV, you load it back. Well, you have to you might get some issue like with the indices and things like that. So it would be nice if you save something and when you load it back, you get exactly the same thing. Okay. You could use a pickle. So this is a code that you could save whatever you want. You can dump into a pickle file, or you could load the pickle file back to your working space. If you save a dictionary to a pickle file, when you load it back, it's going to be it's going to be a set or a dictionary again. If you save a machine learning model into a pickle file, you load it back, it's going to be a machine learning model. Okay, so that's just a convenient function for you to take a look at. So I didn't. So what I had before was just a convolution.pdf and a tf.ipy notebook. That was loaded by the load data function provided by Tensorflow. Okay, so I got the Venice Data Set, and this one is the one that I saved with the pickle file. Just to show you this little convenient tool. Any questions so far before I actually go to neural network? Say that again? All right, so I'd like to show you neural network, the basic neural network today. And very often if you go to a conference or a meetup that is about deep learning, people will often tell you, hey, neural network is not just stacking a bunch of logistic regression together. Why did they say that? Because mathematically or superficially, they are. So neural network, really, if you just want to take a look at the formula, it is just stacking a bunch of logistic regression together. Okay. So that's the first thing I need to show you. Why a neural network is really just you have a bunch of logistic regression together. So let's start with the logistic regression. Well, I'm going to show you with an example. I'm going to show you how you implement a logistic regression with TensorFlow, and then we go to neural network. The example, the toy data set that I'm going to show you the logistic regression is this one. I create this data set with the code here. It's just a bunch of NumPy array. So nothing special. You should be able to understand the code. I'm not going to do that. But a data set is you have one input variable, one dependence variable, or one X column, and one Y column. The X is just a value here from 0 to 6. So the column you have one column, one feature, which is a bunch of number from 0 to 6. And then the label, the Y column is just either it's red or blue. Okay. 0 or 1. And based on the X, you like to train a model to predict whether a particular observation is red or blue. If you just look at this image, if you have a new observation which X equals 2.5, do people think that should be a blue class or a red class? X equals 2.5. Blue, right? Because X equals 2.5 is here, and everybody with X around 2.5 is blue in the training data set, so it makes sense to predict that it's blue. But if you train a logistic regression to make a prediction, what do people think the logistic regression will look like? If I ask you guys to sketch the sigmoid function, sigmoid type of the response or the output of logistic regression on this plot, what would that be like? Yeah, please. A sine function. What do you mean? A sine function like this? Any other idea? We got one sine function. Step function. But how would that be? Like this? But what about this one? So you're going to get this, and then come back. Okay. So people kind of think You should have higher or peak here and the lowest point here. Why don't we just go ahead and train a logistic regression model to see the result? It ends up with this. So keep in mind that the sigmoid function gives you the probability. So I train a logistic regression, I sketch the probability, and then I get this. Logistic regression simply tells you everybody's around 50%. 50% blue, 50% red. Why is that the case? Because it's not linearly separated, it's essentially right. So your feature space is now just one dimension. Linear separate means you could find a cut to separate the two classes. But if you cut it here, you don't. Red and blue are still mixed in one of the subspace. If you cut it here, again, red and blue are still mixed in this subspace. So it doesn't work. That's a good intuition. Is there any other idea? Yes. Yes. Yes, but keep in mind, when logistic regression gives you the probability, it's a conditional probability. It's a probability when x equals to something. So even though overall half of them are 1, half of them are blue, it doesn't necessarily always predict 0.5. The problem was logistic regression won't be able to do this. Because in the logistic regression, when you make a prediction, eventually you pass to a sigmoid function. And sigmoid function is always that. You have only one jump. You don't have the second one.